What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. I got a rock. 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 I got a rock. I got a rock. I got a rock. Rock.
What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock.
What did you What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock. Got a rock. 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 I got a rock. I got a rock. 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 I got a rock. I got a rock.
All right, so today we're going to continue on strings with a couple more exercises, but before we do that, I just wanted to bring your attention to Bits and Bytes today announced the CSAB Food for Thought. This is where you as students can go and speak to your student representatives that are sitting on CSAB and without faculty there, without staff there, as a primer for the full Student Advisory Board panel on next Wednesday. There'll also be pizza there. That's the go-to, always pizza, right? So tomorrow, Thursday, from 5 to 6 p.m. In Avery 19. So that's going to be in the basement right below us here. So if you're interested, go ahead and stop there tomorrow. Again, no faculty or staff will be at that one. They'll be at the advisory panel on Wednesday next week. All right, so last time we left it off by talking about strCpy and strcat and using the byte limited versions along with some pointer arithmetic and pointer tricks in order to do what's called, in order to get a substring. So what I mean by that is, let's go ahead and, I'm done with my name here. Let's go ahead and go with, I don't know, school. There we go. All right, and let's go with University of Nebraska, Lincoln. I'll just leave it as Lincoln. There we go. So what I want to do is I want to isolate Nebraska right there as a substring, right? Is this big enough for everybody in the back? Good? Okay. All right, so I want to isolate the state, right? Just this state right here, okay? To do that, if I attempted to do an strcpy, right, into state, school, right, then first of all, this isn't going to even work. In fact, hopefully, the compiler is going to catch this, right? What would be wrong with this? Why should the compiler catch something like this? Yeah, it's too big, right? 100 characters, right? Or that's actually not 100. It's going to be, maybe the compiler won't catch this because it'll see that it's not actually 100 characters. It's however many characters I've highlighted here, and that'll fit into 50. Certainly if it were only 10, that's way too small, right? And here the compiler should be able to determine that that's way too small. Oh, it doesn't. Okay. Unfortunate. Anyway, let's go ahead and make it large enough, back up to 50 here, and then let's go ahead and copy from school, University of Nebraska-Lincoln, into state. My goal is just to get Nebraska, but if I do it this way, it's not going to work, right? So state is equal to %s and the line state. And this needs to be printf here, right? It's going to copy the entire thing because we're starting at the very beginning of the string and going all the way to the end of the string, right? My first attempt is going to be, well, I don't want the entire string. I just want 1, 2, 3, 4, 5, 6, 7, 8 characters, right? So let me go ahead and use strncpy and specify that I want at most 8 characters to be copied. Now, that's not going to take care of the null terminating character for me, right? In fact, let's just run it like this. And run it a.out, universi, right? It's going to start, again, I've got a couple of problems here. It's not starting at Nebraska, the big N, right? It's still starting at the beginning, but also it's not null terminating. Now, it didn't end up with a segmentation fault here, but if I ran this through Valgrind, Valgrind would definitely come up with there's an uninitialized value somewhere, and so there's at least one error, right? I didn't compile it with the G flag, but it's telling me that the string length, when it tries to go and print the state out, it sees the first 8 things, but it was never the null terminating character was never put in there by strncpy because it did not see the null terminating character in those first 8 characters. So we need to take care of that first. State of 9, or where is it? 9 is equal to the null terminating character. If I'm copying over 8, where would the last value be? At 8. Right? Because it starts at 0 through 7, and then 8. Right? When I run this, Valgrind is very happy about it, right? 0 errors at all. And when I run it, normally it runs exactly as before. We're still not getting what I want, though. I want to isolate Nebraska here. So here's a trick. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? I want to start at the 15th character, 15, right? I don't know if I counted wrong or not there, right? I want to start copying at the 15th character. Now remember, we might have done this very briefly last time, but what are these things? School is a char star, right? A pointer to a string, right? What if I go school sub 15? I am referencing one thing in that array. One thing in that array is a what? Is a char, a single character. Right? So what I want a char star to copy. Right? I want a string to copy. So how do I take a character and convert it into a char star so that it becomes a string? Ampersand, reference it. There we go. Now let's see if this works. A.out. I was off. Where should I have started? 14. There we go. I miscounted. There we go. Nebraska. Okay. Let's run it through Valgrind to make sure that we are not going beyond the bounds, right? Valgrind A.out. There should be 0 errors. We're good. Right? Gee, that seems really, really useful, right? Maybe I should write some sort of a substring function, right? This is a substring. This entire thing is a string. Part of it is a substring, a subpart of it. It's like a subtopic, right? Or a subchapter or something like that, subsection, right? So let's go ahead and put this into our very own function, right? I'll call it home row, substring. There we go. So let's describe what we want out of this. This function takes a string and two indices, start and end, and produces, or creates, let's say, creates and returns a new string, which is a substring of S, let's say string S, let's give it a name, right? Some string of S containing characters from start to end. In other words, what I want to do is something like this, but I would instead specify something like, give me a substring of state starting at index 14 and going all the way to index 22. 14 plus 8, right? I want a substring of size 8. That's what I'd really like. I don't want to have to do this over and over again every time I want a substring. Let's put it into a function. Right? Now let's write that function. What's the return type? Char star, right? Why? Because it's returning a string. Okay. What does it take as its only argument, or as its arguments? It takes a string, and a string representation is a char star. Char star S. Can we improve on that immediately? Are we going to be making changes to it? Nope. So, const char star S. And int start int end. Right. Start index, end index, whatever you want. Okay? So, what's the very first thing you do in any function? Always, always, always. Module 6. Error handling. If S is null, then that's a bad thing, right? What else would be a bad thing? The indices, right? What if the start index is negative, right? Or the end index is beyond the other way. Yeah, so like if there are 5 characters in it, right? You could go from 0, 1, 2, 3, 4. It shouldn't be beyond that, so it's greater than the length of S, right? Something like that. How do I know what the length of a string is? strlen. Wait a second. What if it's not a properly null terminated string? What if it's null? Guess what? We would have taken care of that by checking for null first. So what's the first of the first? Always check for null. Right? Otherwise, this would have segfaulted out. Okay? If the end is greater than... Now, let's think about that. So HELLO is 5. So if the index is 0, 1, 2, 3, or 4, that should be okay. So if it's greater than that, minus 1. Right? Good? Okay. Alternatively, you could have said if it's greater than or equal to, and then you wouldn't have to do the math. Right? Is there any other possibility here that would be wrong? You go from the start to the end. What if they're crossed? Well, what if they meet? That means you just want a character. Why are you using this sledgehammer when you just want to drive a nail, right? If you want a character, just get the character, right? But if you want a string of length 1 somewhere in there, fine, go ahead. But getting an empty string, that doesn't make sense. So if the start is strictly greater than the end, right? If they're out of order, return. Ooh, what? So what's the return type? It's a char star. It's a pointer. What is the only pointer that we can return as an error condition? Null. There we go. All right. Now we know that everything is great. Right? Let's go ahead and use this as an example for what we should be doing. Right? So obviously not this. I'm going to go ahead and put that into a comment here. But I'm going to keep it there just as a reminder. Again, this is my whiteboard up here. Right? If you were actually coding, what you would do is you'd have a couple of screens open, maybe a whiteboard over here on your desk, right? If you were down in the lab collaborating with somebody, you'd use one of those. They have a portable whiteboard that you can move around, right? Something like that. If you want to, if you don't have a whiteboard, you just use a piece of paper. Right? All right. So I don't have state, I don't have school here, I don't have anything. What do I need? What am I copying from? What am I copying to? Well, what am I copying to, first of all? Some string that I'll return. Dot, dot, dot. So what's that string that I'll return? I need to make it. Right? So what does it represent? It represents the result. Char star result. Right? Now, oh, here. Can I do it like this? Result. I'll just make it big enough. 100. Yeah, you can't do that. First of all, that means that you could only ever handle string, like your lab yesterday. It was for a dictionary, so it's reasonable that you'll never have a word that's like 1,000 characters long. That's why we use static arrays in that lab, right? It was safe. But if you're processing arbitrary data, like say DNA sequences that are millions of characters long, right? 100 ain't gonna cut it. So that's reason number one. What's reason number two? Can I return that result? What kind of an array is that? It's a static array. Can you return a static array from a function? No, no, no. Why? It exists in that stack frame. That stack frame is popped off the stack when you return from the function. Everything is deleted. Right? If you tried to do something like this, you'd get a stack smashing event or a segmentation fault or something like that. Right? So no, you cannot do that. What do you have to do if you're going to return a string? Char star result. Or, you know what, it's called a substring. I could call it a substring. That's a kind of icky though. Why? What's the name of my function? Substring. You can have a variable named substring, and then there are going to be various pitfalls that you can fall in later on when we start using or when we cover function pointers. You can actually have a function to a pointer to a function instead of actual data, right? So don't fall into those pitfalls. Call it something else. Right? Result is fine. Right? I need to make a call to malloc, char star malloc. Right? How big do you want it? Well, if I went from 14 to 22, I would need room enough for 8 characters. Is that enough? 8 characters plus what? The null terminating character, 9. How do I do that math? End. Oh, okay, size of, good. Size of char. How many of them do you want? End. Like 22 minus 14 gives me 8 for the example, right? This is why you whiteboard. Do one example and then generalize that example. What are these values? End and start. So end minus start. Right? And we know that this is not negative, invalid. Why? Because we already checked it up here. That's the purpose of error handling. What am I forgetting? +1. There we go. That looks nice. Right? Okay. Now it's big enough to hold whatever I'm going to try to copy into it. Now, just let the library do your work for you. Right? In fact, if you want to take this and put it into a value, right? Int n is equal to this. And then you can go ahead and use n there, right? And where are you going to copy it? Result. And what are you going to copy it from? I'm going to copy it from S, right? But starting where? At start. And that's a char, so I need to change it into a pointer. There we go. strncpy does not take care of the null terminating character for you if it's not there. Right? So we'll go ahead and make sure to take care of that. Result sub what? N minus start. Careful. How big is result? It's already of size n plus 1. So where's the end? Just n. Right? Let's not print it. You don't print things in your functions. And let's return it. Now, let's see if all of that stuff gets us the exact same result here. Let's see, char state is equal to this, and I'll get rid of this. There we go. And I'm going to run valgrind on this in a moment, and I don't want it complaining about memory leaks, so let's go ahead and clean that up. Free state. Hey, all right. All right. School, oh, sorry, what's printf state. What do you, oh, semicolon. There we go. GCC. That's just warning me about an unused and uninitialized. Oh, wait, state, school. There we go. Thank you for that warning. There we go. Let's run it and see. I should get Nebraska now, right? Just like before. And we do. Valgrind. Are we bug-free? Or reasonably bug-free? Yes, we are. Cool. Now I've got one solution that I can use over and over and over and over again. Right? Anytime that you want a substring of something, substring of something, substring of something. Right? Let's try something else. Let's see, 14. That would be 22, 23, 24. 24, and then how many in Lincoln? LIN 7. So 31, 24 through 31. I'll leave the variable name. It's no longer the state, it's the city. Was I off? Oops, I was off. All right, why? 24 through 31. I think it's 23 through 30. Somebody help me out with the math. I can't count that stuff. Nope, still not. All right. We started at what? 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah. Plus 7. Ooh, cool. Why are we getting null? Excellent opportunity to do what? Debug. GDB a.out. I honestly don't know why we're getting null. We should be getting Lincoln, shouldn't we? Let's find out. Let's walk through this program. And I'll set a breakpoint at main. Actually, I don't need to set a breakpoint at main because it's calling this function. So let's set a breakpoint at substring. There we go. Let's take a look at our code. So layout, source. And let's go ahead and run. Right. There we go. Refresh in case we need to. All right, so print S. All right, we got University of Nebraska, Lincoln. Print start, 23. Was 23 correct? Or we think it's correct, right? Print end. Okay, 30. All right, why are we getting null? It's certainly not null. Start is not less than 0. And, I don't know, strlen of s. Print that. Right, you can make function calls too. strlen of s. There, ooh, wow, okay. There we go. There's where we got a segmentation fault. GDB will now terminate. Please report it for instructions. No, I'm not going to report it. All right. All right. So let's go back over here. I think we were going beyond here. 7. Let's try that one more time. Break at substring. Layout. Source. Run. Give myself some more room here. Print end 30. Online character counter. How many characters are in there? 30. So it should be 29 would be the last one. I think that's why. Right? 29. But it still should be telling me that the string length is greater than... Ooh, that's a good question here. End is 30. String length of s. That's properly null terminated. Why are you complaining about that? 30. This is a really cool mystery. All right, let's go ahead and probe it. Int n is equal to strlen of school. And let's go ahead and print that out. N is equal to %d and line n gcc, and we'll just run it normally here. All right, 30. So it should be 29, right? I mean, the input should be 29, but why is this coming up as a seg fault? In any case, it should be up to 29, right? 23 through 29? Oh, no. It should be up to 30. Weird. Yeah, now I'm rethinking that. So if it's 5, the end should still be 4, 1 less. So if it's, let's go with our first solution. That makes sense in my head, but I thought it was equivalent, right? Okay, in any case, maybe my math is wrong in my head right now. Yeah, it's still null, so something's going on there. I'm going to have to investigate that further. Let's go ahead and go with, I don't know, 26. That's safe. Lynn, there we go. Right. That's now telling me that we're off by 23, 24, 25, 26. We're off by 1 somewhere. So that's probably why it's happening. Right? Why is it happening that way? -1 probably. That's the issue. Right? 3. No, nope. It should be +1. Is that right? If I want 23, 24, 25, and 26, 26 minus 23 is going to be 3, so I need to add 1. Right? And that should be then n, and we're going to add that many characters, and then the index n. I think that should be right. Link. There we go. Now let's go back to 30. A dot out. No, still not. Darn it. Oh, that's why. Right. N is going to be at index 29. Thank you. Lincoln, yay, we did it. Right. So there is 99% sure that it's bug-free substring implementation. Right? So a lot more testing is going to be required there. Right? I don't know. What are some corner cases? Let's think of some corner cases here. 0 through what is university? I don't know. 10. Let's just go 10. Oh, lucky guess, or I counted an extra for the space there. How would you know that the space is there or not? Sometimes when I'm testing strings, I like to surround them with pipes so that I know, is there any white space in there or not? And apparently there was. So apparently there's only 9, sorry. 0 through 9, and there we go. Now it's university. What are some other edge cases that you should test? -10, right? That should result in definitely a null pointer. And when we try to print that out, it's going to print null, right? It's going to print a representation of null, okay? I don't know, something valid but reversed, 15 and 9. Right? Basic error checking here, that should be null too, right? One other edge case would be, what if you just want the entire string? 0 through all the way strlen of school. Right. There we go. Oops. -1. There we go. There. Another way of doing a deep copy. In fact, you could erase the contents of this now and simply call this other function over here. I want a substring that represents the whole thing. Right? And then you wouldn't have to have so many lines of code. Oops, don't do that. Right. Okay. All right, so what else did I want to do? Yeah, let's do some more exercises here. Let's do a character counter. Right? So I'll do it down here. This function takes a string s and a character c and counts up the number of instances of the character c in s. That should be even easier, right? That should be pretty straightforward than what we just did. So what should I call this thing? Count char? Count character? What's it going to return? An integer, because there are 3 e's in there. There are 5 x's, right? There are 4 exclamation points. And it takes a string, char star s, right? If I'm not going to be making changes to that string, though, it's better to do const char star s and a single character, char c. Right? And it's simply going to iterate through this, this string, and anytime you see the character c, you'll add 1 to your count. So let's go ahead and create a variable to hold the count. Oops, count is equal to 0. What if I did not initialize it to 0? Is that right? No. Why not? What's in that variable right now? Something, right? Dead beef, garbage, right? Is equal to 0. Right? Now, an idiomatic for loop. For int I equals 0, I is less than strlen of s. Right? You can put that in a variable if you want to, I++. Right? If, how do I get the individual string or individual character at I? S of I. If that's equal to your count, or to your character, then increment count. And finally return count. What did I not do there? No error checking. So let's think about what error checking would look like here. If S is null, C, can you really give me a bad value for C? Not easily. Not really with a character. You would have to assign the character like an invalid value, like -5 or something like that, something that doesn't appear in the ASCII text table. And that would probably be a compiler warning, or maybe even the compiler would change it to something else. Right? It would interpret that signed integer as as some character. You wouldn't be able to do it. You'd have to go out of your way to do that. You'd have to do something like this: char s or c is equal to typecasted as a char -4, right? And nobody's going to do that intentionally, right? Hopefully. Right. All right. Why am I sometimes using malloc to create strings, but sometimes just use the variable name length? Is there a reason for this? Yes. If you just use a declaration like this, char foo 100, that is a static string, right? It only exists in that function. You can't return it. You can pass it to another function, but you really shouldn't, right? And you can't return it from the function. So if you, and also, it's only of size 99. Why 99? Because -1 for that null terminating character. Right? If you need to return it, or you don't know how big it needs to be up front, you need to go with a dynamic array, right? A dynamic character array. Right? So if that's null, we'll just go ahead and return something. So if the string is null, how many s's are in it? Okay. If a string is null, how many x's are in it? Capital X's are in it. 0. Seems to me a way to do error handling, straightforward error handling here would be simply to say there ain't none in there, right? Because it's not a valid string. Okay. All right. That looks like it's complete. Let's go ahead and test it down here. Free state. Let's see. Count char, and I want to count the number of, in school, how many A's are there? Int count is equal to printf count equals %d. I'm just doing ad hoc testing here, right? Sanity checks. Right? How many A's are in University of Nebraska-Lincoln? 2. Looks like it to me, only in Nebraska. Right? Okay. How many Z's are in there? That should be easy. 0. Right. How many spaces are there? Right. You can do spaces. How many n-line characters are there? Right, et cetera, et cetera. Let's do spaces first. We should know that. It should be 3, right? Because there's 1, 2, 3, 4 words here, separated by 2 spaces. Okay. I like that idea. Let's go ahead and remove the spaces. Remove all white space. So let's write this function. This function takes a string s and modifies it by removing all white space characters. Now, all white space characters would include, of course, the space. That's pretty straightforward. But also end-line characters, tabs, carriage returns, right? On an old school typewriter, you just turning the drum doesn't move the typing cursor or whatever it's called. It just goes down one column, right? So remove all white space. Right? Am I going to have a return value here? You give me your string, I modify it, I change it. Do I need to give you anything back? Not really, unless I want to do error handling. Right? Let's go ahead and wait and do that. Right? Actually, no, let's go ahead and do it from the beginning. Fine. Remove all white space. Now, can I do const char star here s? No, because I am going to be making changes to your stuff. I'm going to be taking out all the white space characters. Okay? So change that to char star. Ooh, ideas. So one thing I could do is I could go through, here's the string, right? So I don't know what they are. Anytime I see, let's say I see a space in the first character. We'll go ahead and take all the other characters and shift them down one. Copy them over, right? So suppose that there are 3 spaces and then hi, hello, hi over here, right? I want to shift hi all the way down. If I do that just character by character and say, this is a white space character, shift everything down. This is a white space character, shift everything down. This is a white space character, shift everything down. I'm doing the same thing over and over and over again. Now, if there are only 5 characters and 3 spaces at the beginning, who cares, right? That's not that big of a deal. But if you're processing huge amounts of data, gigabytes of data, right? And you've got a lot of white space characters to shift down over and over and over again. Say 10 million characters and half of them are white space, right? You're going to be doing that operation roughly 10 million times, 5 million times over, right? So what is that? 5 million times 10 million? 50 quadrillion? Something like that? Trillion. 50 trillion operations. You start to notice that real quick, right? On big data. That's not even big data, by the way. Right? So that's going to be very, very inefficient. Okay? We might even benchmark that later on, that naive, stupid solution. So let's rethink it. Ideas? Okay, I could definitely use the C-type library using is space. That's definitely what I'm going to do for a particular character, right? Remember the C-type library? It's got all of these nice functions in there. Is alphanumeric, is punctuation, is space. It's going to return true for all white space characters. So I'm definitely going to use that to determine, is this particular character a white space character? But how do I go about removing them all? I'm not clever enough to figure that out. Let's go ahead and use the libraries to do our work for us, right? What if I were to go through and count up the number of white space characters? Count up the number of white space characters, right? Then what I'll do is I'll go through the characters again. And actually, I don't even need to count it. Let me go ahead and maybe. I'll put a maybe next there, because we will do that eventually, but not yet. I'll go through the characters again, or for the first time, again. If it is a non-white space character, copy it over to a temporary work string. There's nothing saying that we can't create a string and use it temporarily and then throw it away once we're done, right? So I've got my original string here, right? HELLO with maybe a bunch of spaces in between. And I've got my temporary workspace over here, my temporary string that is just as big. I'll go over all of the characters, and if it's a white space character, I'll ignore it. If it's a non-white space character, though, I'll go ahead and copy that over to the second string. I'll make sure that I only ever copy non-white space characters. All right, let's go ahead and try that first of all. First, you need some temporary space. to work in. And this goes to the question that was asked on the YouTube channel. What if I do it like this? I'll say char temp of size 100. Is that going to work? It's going to work for any strings that are less than 199 characters, right? I'll give you one that's 100 characters, and now it breaks. All right, bump it up to 1,000. All right, I'll give you one that's 1,001. Right? All right, pump it up to 10,000. I'll give you one that's 10,001. All right, fine, pump it up to, I don't know, 10 million. And now it crashes immediately. Why? It's stack space, right? Can you put 10 million characters, 10 million bytes, 10 megabytes onto the stack? Right? No, you've stacked your dishes too high. And you've overflown your stack. Right? Can't do that. What can you do, though? A dynamic string, right, is equal to a call to malloc, that is just as big as this string up here. Right? So size of char times strlen of s plus 1 for the null terminating character, making sure that your math is correct with PEMDAS, putting in the p in PEMDAS parentheses. Right? Yep, can't assign that much memory, right? To the stack at least. But the heap, wow, you can assign as much memory in the heap as you want. Right? It's virtual memory. It'll just get really slow if you ask for too much. Right? Okay, so I've got my temporary workspace now. Now I will go through the characters, right? Dot, dot, dot. An idiomatic for loop for int I equals 0, I is less than n, I plus plus. You know what? strlen of s, let's just put that into a variable so that I don't have to do it twice over and over and over again. Right? I'll go ahead and replace it here and here. Okay? Go through the characters. If it is a white space character, ignore it. Right? Otherwise, if it's not a white space character, copy it from s to temp. Dot, dot, dot. So that's where is space comes in. If it's a white space character, ignore it. But if it is not a white space character, then I copy it over. Temp of something is equal to s of I. Right. Ooh, here's where that something comes in. How do I copy over a single character and know where I'm copying it? So if I've got space, H, space, H, space, let me do it up here. If I've got hello, all with spaces in between, and I want to copy it to something that looks like this, right? I is going to iterate on this first one, right? I need another variable here, j, to iterate on the second one, because when I is, say, 0, 1, 2, 3, 4, right? This ends up being 4 right here. That's going to copy over to this one, which is only 2, right? So you've got to keep your indices correct. So let's go ahead and create another variable here, int j, starting at 0, because that's where all arrays start. And I will copy over into j the I. I goes to j, I goes to j, I goes to j. Sometimes it doesn't. If I is a white space character, we don't copy it over. And therefore, we don't increment j. We need to keep j moving along. Right? If we make a copy of a character, j++. Good? All right. What did we not take care of at the end? Is temp a valid null terminated string right now? Nope, because we only ran over the characters, not the null terminating character. That's okay. Temps of j is equal to the null terminating character. We'll do it ourselves. Right. I'm halfway there. What I've done is I've copied the original string into this temporary workspace, removing all the white space characters. Now, I said that I was going to modify your original string. Right? So what can I do now? Copy the temp string back into the original. Dot, dot, dot. And I'll let the library do that for me. strcpy into s temp. And then return. The return type is integer here, so no errors, 0. Good? Let's find out if it works. I'll ask you to remove, what did I call it? Remove all white space? Remove all white space from the University of Nebraska-Lincoln, from school. And print it again. Oh, I don't have it. All right, so printf school is equal to, again, I'm going to surround it with pipes so that I can see that all the white space was removed. Good. GCC, or a.out. There we go. All those spaces were removed. Let's go out back and test it a little bit more. What if I put a tab in there? Put a tab over there. What if I put an endline character over there? Another superfluous space. A bunch of spaces all in the row. A bunch of tabs all in a row, right? Really screw that string up, right? And I still get the same result, right? So, a bunch of white space characters have now all been removed, right? Including tabs, endline characters, etc. Right? Okay? Valgrind, tell me, should I be worried about anything? Yes, I should be. There is a memory leak where? On line 49 somewhere. Right. 49, we allocated this memory. We used it. Once we were done, we used it and copied it over to the original string, and we're done using it. What should we be doing once we're done using memory? Free it. Free S? Yep, the thing that you gave me, I delete it. No. Right. Don't do that. I free temp. There we go. Valgrind is now happy about everything. Right? We cleaned up after ourselves. Again, if you, I mean, you can grow big brain time and think of all these nice, clever things. We did a clever version of this in the morning section. And then I rethought about doing the clever thing and doing the more straightforward thing by simply just using temporary workspace, right? Memory is cheap as long as you're using it correctly, right? malloc, right? And using the heap memory, then you can copy it over to a temporary space. Then you can just clean it up, right? Really quickly here, what would it look like if I wanted a different version of this? Let's go with, let's see, remove all white space copy, right? Const char star s. Right? Now the difference here is this function takes a string s and returns a new string, copy of it, with all the white space characters removed. It seems that would also be useful in a lot of cases, right? I don't want you messing up my string. I want you to give me a new copy with all the white space removed because I want to operate on both of these pieces of data, right? Okay. The return type here is going to be char star instead of an integer, right? We'll do basic error checking, so to do error check. What kind of a thing would we return in the condition of an error? Null, because it's a pointer, right? I made this into a const to ensure that you're not going to change my stuff. Instead, you're going to make a new copy of it. This should be a 2-liner, maybe a 3-liner. Why? We already have functions to do all this stuff. Deep copy of a string. Remove all white space. Right? So let's go ahead and create a deep copy first of all. Char copy is equal to deep string copy. Deep string copy of s, right? Then call remove all white space on, the copy. Right? Then return the copy. Right? No need to complicate it. If you've already got the tools to bring to solve this by bringing them together and combining them, then do it. Right? But that makes me want to redesign this function. If we're going to use this temporary workspace anyway, right, maybe this implementation is the one that should return the copy, and then remove all white space, that's the one that should actually be calling this one instead. Right? So if you've got a function that calls another function, think about maybe changing the design so that this function instead calls that one. Which one is simpler? Which one makes more sense? Which one is more straightforward? In this case, though, this is good enough. Right? There are no memory leaks here either. For 3 minutes left, we can still test this. Right? Remove all white space copy. We'll do it before this. Char star copy is equal to remove all white space copy of school. There we go. And print copy instead. Copy, copy. Free the copy after you're done with it so that it comes back. Yes, I did. Oh, good. This is why we use prototypes. Right? What's wrong here? Remove all white space copy calls this function. Where does that function exist? Below it. So if you have one function calling another function, the order then matters. Unless you do it properly. I'm just doing it demonstration style here. You do it properly and you have prototypes and this issue goes away. Right? See, there we go. It was just a warning anyway. Valgrind, do we have any memory leaks? Nope. And when I run it, beautiful. It all works. Okay. More practice next time.